Greetings. We're going to go over converting decimal to base 2 or to binary, and then from binary or base 2 back to decimal, which is base 10. So usually we have a number as we're used to it so far in decimal, and we use that comfortably. Now we need it in binary. So as I discussed in class, first I'd set up a table. So let's say this is your number, this is your goal from base 10 to base 2, or decimal to binary. Okay, so we're going to go 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, okay? We'll just stop there. Alright, so, and then next, so that's what your table's going to represent. I'll leave a space here for actually ones and zeros, and then down here is just I put my base 10. This is one way to do it. Alright, there are many ways to do this. So 2 to the 0th is 1, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, and you can see the pattern here, 16, 32, 64, 128, 256, okay? So those are our base 10 values. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. For converting this, okay? So 263. So first you want to start with the largest possible number of base 2 that will fit into your respective base 10 number. So clearly 256 is the largest number, so I'll make a mark there. And now I'm going to take 263 minus 256, right? So I'm going to borrow from, I'm going to take 6 from 3, but I got to borrow from 6, so that becomes 5. This becomes 13. So 6 from 13 is 7, and then 5 from 5 is 0 and 0. So clearly I found the largest value of base 2 that could fit into this. So I have an exponent 2. Anyways, so 7. Now we need to reduce from 7. So what's the next largest number that will fit into 7? So 128 is not going to fit, 64 is not going to fit, 32, 16, 18, all the way down to 4 finally, right? So then I just take 4, put a mark here, subtract 4 from that, right? And that's going to be 3, and you can kind of see where this is going. So that's going to be 2. I can subtract 2 from this, right? And that's going to finally be 1. So, and then you can just fill in zeros for the rest. So that's converting to base 2, so we can check that, and most computers have a scientific programmer on them. So if you go to programmer mode, and if I'm in decimal, which I am right there, right, I can type 263, and then if I convert that to binary, right, I get 1 0 0 0 0 0, so 1 0 0 0 0 0, and then 111, so 111. So clearly that worked. Okay. So what if you want to go the other way? Well, it's just this in reverse, right? So if I want to go the other way, let's say I'm given a number here, so I'll clear this out. This is not what we're doing anymore. Now we're going back into base 10, and I'm given, excuse me, 1, 2, 3, 4, 5. I'm given, let's do something we don't know the answer to, right? So I'm given this value, 1, 0, 0, 1, 1. Now all I want to do is I just want to go what I did a second ago. So you're going to have to set this part up right here, and this part like we did a second ago, to convert this, and then it's just pulling out and adding, right? So we have 256 plus 116 plus 12 plus 11. So we're just tallying it basically. So 6 and 6 is 12, plus 2 is 14, plus 1 is 15, carry the 1. 1 plus 5 is 6, plus 1 is 7, and then we just drop down the 2 all the way, right? And these drop down, so 275. So again, we can check that. If we have this as a binary number. So if we have 1, 0, 0, 0, 1, 0, 0, 1, 1, and we say convert to decimal, right? There we go. We get 275. That's going from binary or decimal to binary, and then we did back from binary to decimal.